Hello everyone. How's it going? Sorry for coming late today. One, I was found with fever, and second thing is I'm gonna put down the music a little bit. That's okay. And second thing is I was down with fever since yesterday. I came home and second thing is I was down with fever since yesterday. Just give me a second. Uh, I hear an echo. I think I know why. My bad. Okay. Yeah. And then at 7 o'clock I decided to start streaming, and from 7 o'clock to 9 o'clock I was fighting with Linux to get my drivers updated, NVIDIA drivers updated. And holy shit, it was a fight. Oh my god. But thanks to Linux Stack Overflow, and ChatGPT that I finally made it work. I still have to figure out if it's actually gonna work with CUDA and things like that. I had it set up and then got messed up. But yeah, I have to still figure that if that is working or not. I'm gonna quickly check if everything is good. So I'm gonna mute my mic and I'm just gonna quickly go ahead and see my audio once, and if everything is good, we're gonna get started. Okay, cool. Just give me a second. I hear an echo. Thanks to Linux Stack Overflow, and ChatGPT that I finally made it work. I still have to figure out if it's actually gonna work with CUDA and things like that. Got messed up. But yeah, I have to still figure that if that is working or not. Okay, fine. I think my audio is good enough, and the music is also not blasting your ears. So I'm gonna go turn the music back on. Okay, turn the music back on, and we can get started. So I'll do some algorithms today. Again, it's just one of the easier things to actually start working with. I'm just gonna go to filters. Again, I'm just gonna go back to what it was before. So yeah, that's basically it. But then I also have to, I had to reinstall. I kind of had to reinstall, OBS to make things work again. But I hope things are working now. If someone in the chat can clarify that, yeah, the stream's going good. And my audio is clear, the music is not blasting your ears. Hopefully, things are good. Yeah. I probably have to go to limiter. Hello. Okay, so that's too loud, I think. Hello. Yeah, I think that's pretty good now. Okay, so I hope the audio is not too blasting and everything is good. But saying that, we can get started. Right? Okay. Cool. I don't have anything stupid open, so I can start sharing my screen and we can get started. So what are we doing today? I picked up algoexpert.io. The Leetcode was one of the things was that there's just too many problems to scan through and which one to do. So I feel that this 200 questions of AlgoExpert is really good. If you do not have the subscription, you really don't need to take the subscription. But if you're preparing for something, I would say go ahead and take it. So I already solved, I think, 150 questions last time, but I just reset the data again. Yeah, that's pretty much it, so that I can solve it again. So I solve it for fun. I solve it for, again, going through algorithmic problems again and have fun solving them. But if you're preparing for interview, it seems like a good, resource which will help you two things. So this time I'm going to go with complete one by one. So I'm first going to do arrays, then I'm going to do binary search trees. I think that's fine. So very soon I'm going to make a video and I'm going to do a blog post on count squares. So previously I was solving count squares in a different way, and yesterday night I started solving this, day before yesterday night I started solving this, and I started thinking in terms of space and all that, and I had quite a good solution for it. Okay, if anyone is interested right now to know what the solution is and how we compact the size, I can show right now. But yeah, there's going to be a dedicated video. I think that's the first video that I'm going to make and publish along with the blog that I'm going to do. Okay, so we can start with 4-number sum. Okay. Sorry for my voice, it's a little bit cold. Yeah. So write a function that takes in a non-empty array of distinct integers and an integer representing a target star. I have set my kbps to 24. It still streams at 12 kbps. I don't know what's up with that. Yeah, whatever. As long as the stream doesn't lag. Okay. So 4-number sum. So write a function that takes in a non-empty array of distinct integers, and okay, I need to reshare my screen again because I see it's not shared. So let me again share it back. Now I think it should be fair. Oh, it was already shared. Back. I'm a little dumb. Sometimes it feels stupid. Okay, so first 4-number sum, write a function that takes in a non-empty array of distinct integers and an integer target representing a target sum. The function should find all quadruplets in the array that sum up to the target sum and return a 2-dimensional array of all these quadruplets in no particular order. Okay. If no 4 sums sum up to that, the function should return an empty array. So okay, so you're returning a list of integer arrays. That's fine, and that becomes a bit easier. Though since you're working with integer here, you could have done that, and that would have been a little less on unboxing side, but that's not the point here. The question is, you're given an array, they're distinct integers, and you're giving a target sum. So you have to find quads, which basically add up to the sum. Okay, and it has to also be unique. So as an example, 7, 6, 4, minus 1 is one of the quads, but then minus 1, 4, 6, 7 is another quad, but we don't consider that. So we're always considering unique groups of elements, no matter where they are. Like what is the order, it doesn't matter. The values have to be unique. Okay, that is one thing. So this problem can be taken as an extension of 2-number sum and 3-number sum. So 2-number sum is where we do like a map to do a lookup, but if you have something sorted, you can do a binary search on it. Yeah, I can do a binary search on it. And in a 3-number sum also, what you generally do is you first sort the array, then you take 2 of those, and for the other one you do a binary search because you're sorting it, right? So I feel we can do it in this way, but I also heard of, and that kind of gives a O of n cube solution for this, right? One bad thing about AlgoExpert, it never really has constraints, which means I cannot never really say that, okay, what kind of solution I should be taking into account depending on the input that we have. But we are going to consider that, okay, it's a huge input and try to come up with the best possible solution. Okay. So let's take this example and 16. So let's dive into the problem. Okay. So one of the things we can do here is that we can sort it. So if we do sort it, so what happens if we sort it? Sorted. Oh, this becomes sorted, right? This right here is your sorted list. This right here is a sorted list. And so what happens here is that what you can do, you can take, so since you have quads, the first pair of numbers can go from here to here. So since you already sorted, you have n log n already done for you, right? So that's one thing. So in here, this can go from here till here, because from here till here, the other ones can just make the code, right? So it's length -1, -2, -3, -4. So you have to go to -4, like inclusive of -4. Okay, so that's what you have to do in here. The second thing you can do is, so let's say this is I. Now the second thing what you have to do in here is that you can have J. So this right here is J. Right, so if you have this as J, so this is the inner loop. So if you start from I at some point, and I can be 0 to length -3, this is exclusive, this is inclusive. J can be from I plus 1 till length -2. Length -2 is also exclusive because you can go up till here, and that leaves enough elements to generate the quad, right? Now in the other part, what you can do is you can do a binary search. You cannot do a binary search. What you can simply do is you can take like a left pointer and a right pointer. You can take a left pointer and a right pointer in here, and you can say, okay, what I want to do is, can we do a binary search? Yeah, we can do a binary search, right? Because you have n square solution in here. What now you can do is you have two pairs. So let's say this is the two things, right? So this is what the first pair is, which is 0. So the corresponding sum that you have to generate from two numbers, no, you cannot do a binary search in here because you still have to figure out two pairs from it. So it kind of becomes NQ, which I think is not a efficient solution. I think you can go up to n square. So let's think about that. First, let's do the solution and see if that works, right? So in here, what you can do is you can take a left pointer here, right pointer here, and you can move them towards each other to find a pair of 16. Okay, so in here it is 9. In here it is 9. So yeah, we cannot make a pair in this. Yeah, we cannot make a pair in this because it's 9, right? So at any given point of time, if it is less than 16, we know we cannot make a pair, so we can just simply exit out. So let's see for -1 and 2 for the next iteration. So this is J for the next iteration, right? So this here is 1. So the corresponding value that you're trying to go for is 15. This also cannot do. This here, -1 and 4 becomes 3, right? Corresponding value is 13. So wait. I did a mistake here. I did a mistake here. When you are here, your range is this. So this is 1, and then correspondingly you have to make 15. So this here is what? 4 and 7 is 11. So you cannot make this thing, right? You cannot make that. So when you do -1 and 4, it has to be the 13 as a pair. So this here is your limit. So 6 and 7, and you add that to 13. And for a matter of fact, there can be other values which can add up to 13 in here, because, well, it's distinct in here, but just let's suppose that, you can have fractional points. I mean, it doesn't make sense, but you can have fractional points, and 5.5 and 6.5 would also kind of make the same thing, right? It's 12, 7.5. So, I mean, just to give an example, because there are only two numbers here to work with, but there can be numbers in between which can still add up. So what we do is, as long as the values are less, we increment the bigger number. And as long as it's more, we move the right pointer. That is what we do. So essentially what we are doing here is I is 0 to L minus 3. Inside J is equal to I plus 1 to L minus 2. And on the other hand, we say, okay, so left pointer is basically J plus 1, and then your right pointer is always length minus 1. Okay, so if the summation of left and right is greater than whatever you're targeting, you can say right minus minus. If it is less than, you can say left plus plus, and if it's equal, you can capture it first as one of the possible answers, and then you can say, hey, I need to move both the pointers. So left plus plus, right minus minus. So this is what it is. So you see here, this is n, This is n here again on an average amortized because it's n into n minus 1, so it will still come up to be n cubed even if you like do proper n minus 3 and all that, right? So if you consider this as n, this is n minus 1 and here it is n minus 2, right? So if we multiply all of these, n cube is the more predominant one, so that is what the answer is going to be. I feel that we can go till n square if I'm not wrong, but for now I'm just going to do the solution and see if it works, right? And then we are going to do a little bit research on how we can go down to n square. So 4 number sum. Okay, cool. Any questions till now? 4 number sum. Okay. And of course, at the very beginning you do a sort, so it is n cubed plus n log n, but this is very, very low when compared to n cubed, so we don't care. Amortized is that. Okay, so we do that, and now can you complete? Wait. Your I can go up till here. So this is -1, -2, -3, -4. So this is correct. Which also means that J can go up till here. Because okay, cool. This is cool. So right is always this, and we can extract this common part out. Okay. So you have that. Int complement is but you always have to kind of do this, right? So let's do left is, and why do we do less than and not equal? Because it cannot be the same, right? So we do less than. So once we do less than, we can say sum equals, can you finish it? I plus left, but that is correct. If this is this, then we have to capture it. So let's call this quartz. Okay. So now here we can simply say quartz dot add this thing and right minus minus, left minus plus plus. Else if sum is this, so it's less, left plus plus, else right minus minus. All right, and in here you can simply return quartz. We don't have to do anything extra here to avoid duplicates because of the fact that clearly says here it's distinct integers. So we should not hopefully have duplicates if my understanding is correct. So let's see. Oh, you couldn't pass because you fucking idiot AI. I mean, I should have seen that, but yeah. So this passes. So let's actually go to the test and see if it passes. Cool, everything passes. So let's submit the code. So one thing I want to do here is Leetcode for number sum. I want to see for sum. Yeah. So I want to see if it actually passes in here, right? So it's kind of a little different, but we can make a change accordingly. So let's actually copy it in here. Right. So this here is a list of integer. We call this target. So here let's just change sum. Here we call it array. So let's do that array. So less things to change. And in here, what we can do is list of this thing. Okay, so in here there is duplicates, right? So we have to do a little bit mechanism here. So what we can do is if array of I is equal to array of I minus 1. So this is how we are skipping duplicates, because if we have already seen the value, I want to continue. But this can fail because I starts on 0, so I should be greater than 0 and this. Okay. Similarly for j, I wanna do a little bit of bookkeeping to avoid duplicates. I mean, we could have taken sets and all that, but it's more memory heavy and this is more better, right? So it's greater than this, similar to how we did there. So j, if it's equal to j plus 1, we do that. In here, again, if we can copy paste this code, if left array of left is equal to array of left minus 1, we gotta say left plus plus, and then we're gonna have to continue. But then left also needs to be greater than j plus 1 and this. So this should be it to remove the duplicates, right? So we're just looking at the previous element if it's the same thing, and because it's sorted, it's gonna be the same thing. So I really don't want to take the first number at that for any of the sequences that we're going to, right? So if you submit this, I want to see how exactly it fits. Awesome. It doesn't work. Wait a second. Are you telling me it's an overflow issue thingy? What is this number? What is this number? Okay, this is an integer, that's not an issue. But so it is overflowing. So in here, that kind of becomes easy. Now let's check this. And there's a little bit of lossy things happening, but I think that should be fine. What the fuck just happened? Why on earth this is working like this? How it's working? It's supposed to be. Do I need to change one of them to long? Because if I don't cast it, it's still gonna do an integer arithmetic in 32 arithmetic and then cast 2. So I have to cast. Okay. So now this works fine. And what I have to do is quickly do a submit. Okay. So it still is not on a very high distinct. And if I look at my submissions, this is accepted, this is not. But yeah, even if I look at here, but this is NQ, right? This is NQ. And my question here is that can we do n squared? So let's ask ChatGPT. Noted, I'll be straight to the point. Code, blah, blah, blah. I had to give it a lot of this thing and say, don't yap. I had to say that, otherwise it keeps on yapping. So that's one thing I don't like. Okay, so solution for a four-sum problem. Now, time complexity is can we do better than this? I feel like we can do n square. I'm just not sure. I think because I have been doing n cube solutions since long, and I just feel like we can do an n square solution. Now let's see what it has to come up with. Before that, okay, so this is pretty good, and I think we can do a notes extension of 3-sum problem. Sort the array and then just extend the 3-sum problem with 3 pointers. Use the trick of skipping same numbers in the sequence of each pointer to avoid duplicates. Leetcode time taken is interesting. One thing is that I don't look at 18 milliseconds or something, but because there are even hacks, Leetcode time taken hacks. I think it happens with Python. No, bro. Yeah, it's right there. So it has to something to do with write or something. Okay, no, I think they're talking about correct things. Yeah, anyways, I don't know where exactly it is, but you can essentially put some metadata in the code which will change your this thing, the time taken, the actual time taken here. It will take you to top. Yeah, it doesn't happen with Java. It doesn't happen with Java. If I submit it multiple times, it's still gonna roam around in the same place. Yeah, just so again. My previous solution here is 26 milliseconds, 25 milliseconds. That's something that I'm definitely going to look for. And 18 milliseconds is again the same solution. I'm pretty sure it is the same solution. Yeah, it is the same solution. If you're looking at minor optimizations, we have to and we should be looking at the code that is generated for the compiler, for the JVM. Alright, or if you're writing native code, you have to look at the assembly instructions and you can take out instructions. I'll give you an example here, okay? That, not this godbot. I'll give you an example here. I think last day I was looking at it. Yeah, okay. So this is Java, right? So it just generates not exact assembly, but it generates assembly for your JVM. But it should be the same thing with C code also, which generates this thing, right? So this is unoptimized codes. We don't have any optimizations. Maybe 25 is already there. 25 is not there. So we are still working with 24. 25 might be a little bit faster. Okay. So let's say there's a function which really doesn't matter what the function name is. Okay, really doesn't matter what the function name is. It accepts two integers, a and b. What is the compile code? The compile code is iload1. Iload1 is basically loading a into memory. iload2 is loading a into b into another memory, well, registers. Then you say I add, so an integer add, and then it stores the value into some register to actually return it back, right? So this is how the code is. What if I just do a +1, which is a constant? It's going to load that constant and it's going to add again. So even though you have written a single line, C code, GCC might what is that called, optimize it out. But in here you have two extra this things in here, right? Instructions. So definitely it's going to be a little bit slower. So this is a very small example, but this is just to show that if you are looking into very minor details of optimizations, this is what you have to look for, and not like these numbers are not really something you should look for. Okay, what you should look for is that, oh, I know this problem can be solved in a better way or in a more faster way. So even if I'm at 18 milliseconds, or even if I'm at like this thing 1 milliseconds of runtime, I feel there's a better optimizations that we can do. Let's see what this bugger did. Yeah, so he basically, look at that, he basically created his own list, new abstract list. Oh no, okay, so he the fuck is an abstract list? Is it something that Java does? Okay. But yeah, he has done his own optimizations. This is what I'm talking about. He has done his own optimizations, and this is a hack. This is a hack. He has done his own optimizations because it might be generating more better code on runtime, on compile time, right? So that's something you have to look for. So yeah, again, this is more minute details. This really doesn't matter. Okay, my question was to this guy. Okay, one thing I quickly want to do here is that how do you write a C code? Can I quickly do a C code in here? Function, wait, int function. So int a, int b, return a. So we can simply do void int I equal a plus b. So that's one thing, right? And if you look at GCC compiler, let's look at GCC compiler. How do you change it to not Java? Bro. How do you change it to not Java? See? Okay. And now that I remove that shit, how do I bring it back? Well, I messed up. Okay, I definitely messed up. How do you bring it back? How do you bring it back? Become a back. Gotcha, become a patron. I don't want that. I want the assembly code. If source exclude. Why did I have to do it, man? Why did I have to do it? Anyways, let's not waste time right now. But yeah, I'm looking for more. This is what I'm saying. You can use a pair sum hash to get an OFN square time and OFN square space. Recompute accumulate pairs by sum, for which, okay, that makes sense. So you already iterate over each pair and you add. Hey. No. You already add over each pair and you try and figure out what are the pairs, some pairs that you have. So there are certain sums that you can generate using two numbers. This is what you're storing. Okay. This solution is going to be a little bit slow, by the way. This solution is going to be a little bit slow because you have an int here, which is a primitive, and here you have an integer class type, so a wrapper, so a box type. So there is gonna be more time spent to do unboxing and boxing. So that is what is one of the things we really want to avoid. So there are again more tricks and things like that to avoid that. So you're starting from 1, you go till n-2, find complements pair using n. Okay. You need something. Wait, what the fuck you're doing? From 1 to n-2. Okay, so you're going to the second last element. You're going to the third last element. From 1, find the complements using pairs ending before I. So you start from here, you go to the end, and you add up I and j, and then you realize what is the target that you need. Okay. So if this particular thing contains a need, that is when you try to do something about it. And if not, you just ignore it. You don't add it back to the... If it doesn't contain what you do, just ignore it and you move forward, okay? Okay. Yeah, then again, this will be slow because you are creating a set. So this solution should be ideally slower than what I just did here. So solution, I think it's not static, but we'll see. Yeah, it's not static. It doesn't even work for the first one. because for the first one. So it's kind of like stupid as. Yeah, I'm not gonna look into that. I'm gonna look into that later on. I feel like we can do it. So check if we can do of n square solution instead of a cubic one. Yeah, that's for later. That's for later. That's for later. Cool. Then we can go ahead and do subarray sort. Let's move on to the next one, I suppose. Write a function that takes an array of at least two integers and that returns an array of the starting index and the ending index of the smallest subarray. Smallest subarray in the input array that needs to be sorted in place in order for the entire array to be sorted in ascending. If the input array is already sorted, the function should return -1, -1. Okay. So you're giving an integer array. What you're trying to do here is that you're trying to figure out a particular array. You're trying to figure out two indices of a subarray, of the smallest subarray, which needs to be sorted so that the entire array becomes sorted in ascending order. Order doesn't matter, probably it matters. If the input array is already sorted, you should return. That's fine. So there are two things that we need to figure out. We need to figure out till what part it is sorted, from where it is not sorted till where it is not sorted. I think that is, if we figured those two things out, we can answer the question. Because even though we say shortest, it's kind of a bummer thing to say shortest subarray, because like let's take this example, right? Let's take this example in here. So looking at this particular thing, let's just assume that, let's not looking at the integral values, and let's just say that from here to here it is not sorted, but also from here to here it is not sorted. Well, to make the entire array sorted, I need to sort this part. Even though it says smallest, I cannot say I'm going to sort this because it's small, sure, like smaller subarray. Sorry, because this chunk may be sorted, this chunk may be sorted, but technically the entire, like if I look at intervals, right, there are smaller intervals which are sorted, unsorted, but the entire, on a vaster picture, the entire thing is unsorted. So I need to sort that shit to get my entire array sorted, right? That's one thing. That's one thing we should be taken care of, right? And essentially, I think the question boils down to find an index from which it is not sorted. Find an index from which it is not, like on the right hand side, find an index from which it is not sorted, right? That's probably what we're looking for. That's probably what we're looking for. Sorry. Well, you jump in here. I think the order is important because it says ascending order. So this thing is either equal to or increasing. This thing is equal to or increasing. This thing is equal to or increasing. Okay, same. This is where a blunder happens. So something should have been bigger than 11, but you have found something small. So this is where your first problem arises, right? Then you again have something which is increasing. Then you have something again, a blunder happens. This here is increasing, but I feel that is not the correct way to do, because 7 ideally should be bigger than 12. That would be the true sorting, right? So 7 is not supposed to be in here, even though like it is bigger than like -1 position, right? So that is what we have to think. So we can use a stack to keep on adding things. So if you use a stack, it would be 1, 2, 4, 7, 10, 11. 7 is here. It is not correct. So I don't push it to the stack, but I record this, whatever this index is, right? So let's say I. We record that index. 12 is greater. 6 is not. So whatever I1, I2, I3. But 7 is also the issue. 16, we are good. 18, 19. So if we take this, we kind of don't need the stack, right? Because we can do a running max. Because we don't need this entire sequence, I feel. We just need to capture this last one, where this last issue happened. That is where I need to plug in my fix. That's one thing. This is the place where I need to plug in my fix, because this part is already, sorted. According to the rest of the array, this part is sorted. Iska life sort hai. We don't have to bother about that. Till here somebody messed up, so we need to patch from here. That is interesting. And I feel that is the rightmost index. If I do the same idea on the left hand side, where it is 19, 18, 16, 7 is good, 6 is good, 12, it's an issue. So I1 is 12. Okay, let's just say again, I1 is 12 because you have a mismatch there. 7 is another issue. So I2. 11 is another issue. 3. 10 is another issue. I4. 7 is again another issue. I5. Then you come to 4, all good. 2 all good, 1 all good. So I5. So technically this was I5, and yes, this is the answer, because from here to here your thing is messed up, right? Your thing is messed up. So let's do one quick thing in here. Let's quickly take this part again, and we know for a fact that your patch needs from here to here, right? 7 to 7. Yeah, 7 to 7. So that is correct. So one thing what I can do is I can just say, let's copy this guy. Okay. And I don't want this Java thing in here. This is more useful. So let's sort this guy first. So if I sort this guy and if I just plug it in here, it makes sense, because 1 to 4, 6, 7, 7, 7, 7, 7, whatever, 10, 11, 12, and the rest of it is sorted. So this kind of makes sense. So to find the subarray, if I just say to find the places where I need to patch in things, from where to where I need to patch in things, I would run a from left to right, I would say max. If not greater than current max, well, if not greater than equal to current max, patch. That's a patch index. And this is gonna be the rightmost patch index. And if I go from left to right and I say min, the same concept, if the current element is greater than or not equal, just greater than current min, we patch it, and that's the left patch index. That should be the entire solution. Again, Algo Expert doesn't give any constraints, so I can just very much assume that it's a huge S array, and O of n plus O of n, which some people in one of my whatever someone told me is 2 O of 2n, and I said, yeah, it's the same thing. No. And you, like, it was a different problem, and you could do it in one pass, and I just couldn't come up with that, so I did 2 passes. And like, no. Well, a better answer to that would be, you're still iterating twice, so your actual time would be doubled. Well, it's definitely will be double, but can be moved, because if you're having context switch of threads and all that, it might take some more time where your actual running comes into the the context for run and all that. But yeah, that person was very much convinced that okay, it's O of 2n only, theoretically also, which is not the case, because 2 is a constant, so we don't factor in any constants when we talk in terms of bigger notations, right? So we don't do that. But yeah, I feel this is the answer to this question, so let's quickly code it up and see if that works. Okay, I don't remember solving this problem. Maybe I'm solving it for the first time. I don't remember. The only problem here is once you delete the data in Algo Expert, your data is actually gone. So it just tells you last time how many you actually solved, like total. But it doesn't really tell you if you solved this and what was the solution you did. So it's gone means gone. Well, that's correct. You said make it gone. and they ask you a consent, right? So I guess that's fair. So what is that we are doing in here? What is that we are doing in here? So we have to first go from left to right to find out the rightmost index. Int right. So there's one more thing, right? We can return -1, -1. So definitely -1 is an invalid index. So we can do that. For int I is this, but we're gonna start with this thing in here. It doesn't quite come with constants, so it comes with constants. It says at least 2 integers, so it comes with constants. So we're gonna take that constant and move forward. I'm not gonna add any validations in here. This is not production code. Who writes algorithms in production code? I mean, we do. I have written it. I have seen people write it, but it's very less, honestly. Very less. Usually it's graph stuff that we do. Okay. Anyways, what am I trying to do in here? I'm trying to say that left is -1, right is -1, and then in here, int current max is array of 0. Look at that. AI knows, or it heard me. It's either of the two. Okay. So if array of I is less than, and let's do less than current max, so we have a problem, and we can say why is current max equals 0? Like, the fuck you're telling me to do? Did you just okay? Anyways, so right here would be 1 AI. But the question here is, then though I will never get current 0 as one of the answers, right? Because technically speaking, you want -1. So technically speaking, let's take this thing in here and let's keep it there for now. If I have 6, 5, 4, 3, 2, on one side you would have 0. So technically speaking, yeah, how would I ever get 0? How would I ever get 0? How would I ever get 0? So I feel this is wrong. This here is wrong. What I in fact need to do. Also, one of the things here is that how would this work, right? So you have to think of this edge case also. Because if I start looking from here, and this is an issue, I would immediately say that, oh, do this here. How did we do in here? So if oh wait, this is correct because this is right, so it can never be 0. I'm dumb, my bad, I am dumb. Okay, and in here you can simply say current max is equal to, now you complete. Okay, so that is how you get right side. And current min should be -1, which you cannot do, so you can say array length -1. We can extract this out to length, and in here you can start sorry, then -2, 0, so just change it to minus, and if this is greater than current min, then left should be I. Otherwise, current min should be assigned to this. And then you can say, nice one, thank you, left, right, current, sub return. Feel that should be the answer, right? Because when we're going left to right, we're considering the maximum. And if any number is less than the maximum, not equal to, but less than the maximum, we are saying, oh, this is the index where we need to patch. And as we scan through it, it will give me the rightmost one. On the other side, if you start from the end and we go this side, and if any number is greater than the minimum that we have already occurred till now, that's where you need to patch. So patch that. You patch that. Cool. We have to now look for this particular thing, which I think was 47, something like that. But yeah, we'll give you the expected answer. 39. Okay. Let's submit. I should have run it again test, but I mean there is no. Okay. Cool. Cool. So that works. How do you write the notes for this, right? Scan from left to right, from 1 to length minus 1, and keep track of current max. If any element is less than the current max, the index needs a patch. Record. Once scan done, the patch index should be the rightmost patch index. Do the same scan from right to left. From length minus 2 to 0, and consider same logic with current min, which should give the leftmost indexed patch. Then turn the values and be happy. I think that should be a good enough notes for future me. Okay, cool. This works fine. We can move on to the next one. It's already 10:24. Anyways, like I said, I fought with Linux for almost 2.5 hours or 2 hours, something like that. And I don't have fever now, but I have a lot of headache. But I still thought I'd do something productive today because the entire day I was sleeping. Anyways, largest range. Okay, let's go for the next one. Any questions, anyone till here of what the fuck I am doing? Okay, cool. Write a function that takes in an array of integers and returns an array of length 2 representing the largest range of integers contained in the range. What? The first number should be the first number in the range, while the second number should be the last number in the range. What does this mean? Write a function that takes in an array of integers and returns an array of length 2 representing the largest range of integers contained in that array. Okay? The first number in the output array should be the first number in the range, while the second number should be the last number in the range. A range of numbers is defined as a set of numbers that come right after each other in a set of real integers. Consecutive bolna. Okay. For instance, the output array 26 represents a range. Okay. So basically, you're given a list of numbers and you have to figure out if it is you're just given a list of random numbers. Can there be duplicates? Is a question that takes in an array of integers and returns an array of length 2 representing, doesn't quite say duplicates, unique. Wait, unique is there. Where the heck you're trying to find out unique? I think it's within the hints or something. No? Doesn't have unique anywhere. Still finding. Okay, I don't know. Anyways, so your problem here is that given this particular number, you have to given this particular array, you have to find the largest consecutive range of things that you have, and you take the largest range and you just take the left end and the right end and you return that. and there can be no answer which is like you don't have an answer, because if you have 1 and 11, it has to be 1 1, right? So that would be your solution. Where is run code? Right? That would be your solution. Yeah, it has to be 1. Well, technically speaking, I think it says that okay, there has to be, you will have only one largest, so we did a little problem in here because there are two largest ones, but ideally speaking, both of them are largest. But that's fine, I suppose. That's fine. So one of the things which comes to my mind is we just sorted. That's all. We just sorted. What else? So sorted would become this. And you can just start scanning from here. You can look at one number before, and till the time it's +1 for you, you keep on iterating. If it is not, or you can simply do a while loop. So you can do a while loop, and you can start wherever there's a matching thing, you can start scanning. So that would be it. So that would be the solution, which would be n log n plus n. Then this is a more predominant one, which is a more predominant thing. The question here is, can we do better? Let's see if it actually gives a timeout or something like that. And what is the name of the problem? Largest range. Largest range. Okay. So here is it, and we just say arrays.sort. So int current 0, int left is -1, right is -1. This will definitely be overridden, so we don't have any problem of what we start with. Yeah, okay. So while current is left less than this thing, so let's actually extract this guy out. Okay. We want to start with 1, and here what we can do is, array of 0, array of 0. We can start with that, I suppose. Okay. So if current is okay, in start equals array of current. Okay. Now, what you can do in here it's a little bit weird, because if I start from here, there's a starting point. What does it say? Array of integers and returns blah 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 represents the largest range. So can it be empty? Let's see that first. Can it be empty? It can be empty. Give 0 0. What? Real numbers are any number that can be placed on a number line, encompassing both rational and irrational numbers, which means so why on earth are you telling me that this is 0 0? It could have been anything. It could have been -1 also. So I feel they don't have checks for empty arrays. Wow. Okay. That in my opinion is really dumb. So this is what I don't like about platforms, is that you're not really making production grade code. You're just trying to do so if you guys have, so I have 10 years of experience now, and like 10 years back, I don't know what they do now. When I was interviewing for Infosys and for a lot of companies, I think Tech Mahindra I interviewed, or I forgot, there was a company called anyways, I forgot. So everyone had this thing where you had a logical reasoning or analytical something there, where there would be questions and it would be very, very simple maths of 10th, 11th, not 11th standard even, I would say 9th and 10th standard. Something like, oh, you bought a stock for this many amount of money, the stock got split, what is the profit, blah, blah, blah. Or even simpler things like you got a stock for this amount of money and it's at this amount of money, how can you make profit? Things like that, right? So like how you have in CAT exam, analytical reasoning, something. All right. So that is what it seems like. Just with code, it's not really production code, because I have written a lot of algorithm production code also. But this doesn't seem like, yeah. This doesn't seem like it. This doesn't seem like to care, like edge cases. It's just stupid. So we update into preparation. There's no way of knowing who is coming to this website, right? Traffic. You have 22 clones? Really? Or is it just me? I have doubts whether it's just me. So, wait. Why do you do the opposite way? Why can't you write 511? This is American way of writing things, right? 1105. So in the last 14 days, you had 22 clones, but out of which there are 19 unique cloners. Visitors were 50 in total. 3 unique visitors, which means the same guy came in and kept in. I feel like this is me. They don't have correct analytics. I just feel like it. Referring sites and popular temporary are available because like I'm just wondering, I shouldn't give a wrong impression of how actual code should be written. People are actually looking into the code into this repository. Even though I've written it, like I'm just gonna do algorithm stuff in here. It says interview preparation because first I thought it's gonna hook in people and I'm gonna get 1 million stars, which apparently is not the case, right? So that's fine. How else can we actually see if it's actually so is this about push only or about clones also? Action usage metric. Can you tell me exactly? Okay, this is about your this thing, average job run. We don't have any job. What the heck you're running? Acha, okay, that's why you don't have anything. So it just tells you that these are some of the things. Maybe these are filters or something. I don't know. I cannot click it. Contributor search for no, for sure. Only thing I'm wondering about here is that traffic, which says there are visitors. So I'm just wondering if people are actually coming and looking at it. Yeah, I mean, that's fine, I guess. Okay, anyways, so start is this thing in here, right? So start is this thing in here. Just grab stuff here. Let's think about this for now. So, if array of current is equal to array of current minus 1 plus 1. If that is the case in here, what I'm gonna do is int start is gonna be current minus 1, and while current array of current is equal to array of current minus 1. See, I'm gonna say current plus plus, but this can go. So current should be less than length and this, right? So that is the bound check that we're gonna do. Once we have this, int range should be current minus 1 minus star plus 1, or basically it can be done like this. If right minus left plus 1, if range is greater than this thing, so left can easily be start and right can easily be current minus 1. Else current plus plus. Smooth forward. That's what you do. And in here, you can say, what are you suggesting? Array copy of range action. Okay, so it's a different thing, but left, right. This should be the solution. This should be the solution. That is what I was talking about. So in here, we can simply say if length is 0, turn new int 0 0. I mean, I have to hard code it. What else can I do? Right? It doesn't give a proper answer of what I'm supposed to do in here, but looking at it, I saw we can hard code it. So it's gonna hard code it. That's all. Deal with it. And for this one, the answer we're expecting is 0 7. 0 7. Let's run all the tests and see if it could. It didn't pass quite a lot of tests. So it is 1 and 2, but we return 0 and 1. Oh, my bad. Sorry. I'm really sorry. How did the other things pass, or just probably wrong? That passed even less stuff. Oh, no. I get it, because our return is wrong. How did the other one pass? So like it was coincidental that it passed. Okay. So a lot of things pass, but this didn't pass. Array index out of 1, index 1 out of bounds. Where exactly you failed? Line number 28. Here. But I did write current minus 1. What is the input? It's just 1. That was correct only. Yeah. So this fails for a different reason. It's 12 the same. Okay, I want to take a quick break. I'm going to do a quick break and then I'm going to be back in 5 minutes. But then we are going to quickly end the stream because it's already 11:30, 10:30, 10:45. Yeah, I'm going to take a quick 5 to 10 minutes break. I'm going to refill my water. And yeah, till that time, enjoy some music. enjoy some music. we are back. We are back. Okay. So, since the time I actually changed my Wi-Fi adapter, this has been going pretty good. I've also, in my output, I've given a second. Why did you say 1200 kbps? I explicitly changed it to 24,000. See that tomorrow. Let's see that tomorrow. It's a tomorrow's problem, not today's problem. Okay, so let me reduce the music a little bit now, and we can get started. So we have failing test cases. Awesome. Awesome. But we sorted the array. So why on earth are you being a jackass about it? Let's look at it. Let's look at it. Okay, so let's debug this shit. New largest this thing. Largest dot this, and then here I'm gonna say, well, I have to now wrap it. Erase. Static. Oh, static. Well, did we not change it here? We didn't change it here. We have this. This. (12 to 19) it says, but the answer here is -1 to 19. So let's actually look in here. I get it. So you can have duplicates, and that's the problem. That's the problem. Okay, so you can have duplicates, and that was the problem. Well, one of the things we can do in here is this. Oh fuck. I have bounce check everywhere. So what is the issue? And where did you fail line number 20? In here you failed. I think you have to do it like this. Okay. Okay, so that solves the problem. But since we have duplicates, this is n log n. And one of the things we can ideally do in here is use a set. We can take a single number and we can try expanding on both sides. And expanding on both sides should be easier to look up because of set. If you put everything in a set, right? So that increases memory but decreases time speed too often. But how do we know? Because so if it's 2, 1, 3, from 2 I expand on the left side, so 1 and then that stop. On 3 I would expand and then that stop. But when I go to 1 again, again I know that, oh, I can expand. So how do we avoid that? So one of the things we can do in here is we can say, if you're visiting an element, remove it from the set. If you remove an element from the set, you're not going to process it. So that would avoid the sync, right? So essentially what we can do here is that we can say the int left is array of 0 and right is also array of 0. Very good. Okay, so that's that. You say that is that. Then we have set of integer like this. For int num in array, you add everything to num. Okay, now you can simply say num to array. Now if set dot contains the num, if not, we can say just continue to the next element. We don't want to process it. If so, what happens here is that int L can be num minus 1. So while set dot contains L, you say L minus minus, and before that set remove. We can also inline it like this, yes. Int this thing and plus plus. Okay. Int range, we can keep the largest range in here. Largest range is 1. Because it's the same number, so the largest range is 1. So int range will be r minus 1 minus L plus 1. So these are inclusive plus p. So if you take it like this, it's gonna be like this and it's gonna be like this. So this can be omitted. Let's be a little bit more explicit so that we know exactly why we are doing what. If range is greater than largest range, you can simply say largest range is this. Left is gonna be L plus 1 and right is gonna be R minus 1. Now why minus 1 plus 1? Because we skip over to the next element where it doesn't contain, that is when it would break, right? And then in here, return new, we can simply, oh, that is also wrong, so I have to anyways write return new int left right. What about now? Minus 119. So this now is an O of n operation. Well, we never use a lens, so we can omit it. Hello Nonta, but we increase a little bit space. So we reduce from O of log n log n to this thing. So this also works. So there are two solutions that we can go with. Depending on the constraints, we can go with either n log n, so we sort it and then we have to do it that way, or we can use a set if it's still more huge number arrays that we are looking for, and we have to go with the O of n solution. But we have to take into consideration that you are using extra O of n space, and also it's an amortized O of n because these lookups are not always O of 1, so it's an amortized O of 1 lookup, right? So you have to take that into consideration. So let's actually write some notes. Push all elements into the set. Iterate over each element in the array If not in set, skip it. If in set, expand from num -1 till num -1 is present in set. Remember to evict it from the set if present. Do the same by increasing from num +1. This would give the range of elements which are present, range of consecutive elements which are present in the original array. Then we can simply do a largest range check and reset the values. The space is a constraint. We can do a sort and then move around the cursor if array of current is equal to array of current +1, or the heck, duplicates to check largest range of numbers present in the नौनता नो वो लाइट है, वो लाइट गिरेगा नो okay present in the array. Ooh, I think that's pretty good. Okay, I think it's already 11 o'clock and maybe we have time for one more problem. So how many problems will we solve today? 3 problems. So can we solve 2 more problems? 2 more, just 2 more. And 2 more hard problems are left. So reds are usually hard in here, so 2 more hard problems are left. Can we do that? My cat is pulling at the lights that I have set up. And he's definitely, well, it's not doing it. Min rewards. Oh, I have done this problem multiple times. I think it's also on Leetcode. Min rewards. Good. Candy. Min candy. Yeah. So the range children, I have solved it. Yeah. Standing in a line, each is assigned a rating and things like that. So this should be fairly simple to solve. But as we do, we're going to go over why the solution works and how it is. So the problem statement is very simple. Let's go for problem statement. Imagine that you're a teacher who has graded the final exam in class. You have a list of students scored on a final exam in a particular order, not necessarily sorted, and you want to reward your student. You decide to do fairly by giving them arbitrary rewards following 2 rules. All students must receive at least 1 reward. Any given student receives strictly more reward than an adjacent student immediately to the left or with a lower score, and must receive strictly fewer rewards than an adjacent student with a higher score. So write a function that takes on a list of scores and returns the minimum number of rewards that you must give out to students to satisfy the 2 rules. So rules are very simple. You're given a list of ratings for your students, right? You're given a list of ratings for your students, and every student must get minimum 1 candy. But we have to take into constraint that a particular student should get more candy than its adjacent student if the score of that adjacent student is less than. So if I do a diagram in here, so if I consider this is me, so I'm student 1, student 1, the score is less, I have scored less than student 0, so my number of rewards or candies, whatever, has to be less than, strictly less than s of 0. But I have scored more than 2, so s of 1 should be greater than s of 0. Okay? So that is what this thing is about. The question here is, okay, so it says you can assume that students have different scores. In other words, all the scores are unique. The reason why I was thinking about it is because what if this candidate also scored 4? Do we have to give the same amount or what? But here the entire point is that every number is unique. So it kind of becomes a little bit easier, right? Maybe I should solve with the same number of this also, because I say it becomes a little easier. So I don't know if it's actually becoming easier or not. But yeah. So one of the things that we can do here is that we can say, oh, we give this guy 1 candy. So we give this guy 2 candy. We give the first guy 1 candy and this guy 0 candy. This is not allowed. What you're supposed to do, in fact, is you're supposed to give everybody at least 1 candy. That is one thing that we have to take. Okay. So that's one thing that we should be aware of, that everybody should be having at least 1 candy. So one of the things we can do here is that we can start looking for local minimums. We can start looking for local minimums, right? So local minimums will be having 1 candy. So if you take this into account, this is reducing, right? So if you take this into a graph, basically, if you take this into a particular graph, this goes like this, and this is where the dip is 1. And then it goes up to 3, 6, 7, let's say something like this, or 9, actually, so this needs to go up higher. And then there's a dip in here. Right? So these are 2 local minimas that you have. And one of the things you can do here is that you can say this is 1 and 1. It has to be 1. These 2 things has to be 1. Right? So one of the ways to actually figure out the local minimas is that if it's the last element and the previous element is greater, so it means it's this thing, or otherwise both the sides are greater than 1. So that is also a local minimum, right? That is also a local minimum. Like this, you can figure out what the local minimum is. The next point is, how do you actually give them candies? What you can do is you can record, so this is 0, 1, 2, 3, 4, 5, 6, 7, 8. So you can say 3 is one of them, and then 8 is another. And you can have 2 arrays where you can say that sorry, I had to respond to a text. Okay, sorry. Okay, so coming to the point. So what you can do is you can expand on both sides. But here is one thing that you have to do. You can take the same array. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 carry. So what you can do here is that you have to start from here. So you can give them 1 and 1. And you expand on left hand side first. So for the very first element, which is 3, so you can push into a queue, I guess, and you start expanding from one place, right? So you start expanding from one place. This guy is greater, so you give it 2. This guy is greater, so you give it 3. This guy is greater, so you give it 4. Right? And a matter of fact, you know that would be greater, because otherwise it would have been generally a local minimum. Or it can also be reducing, so that you can reduce the number of particles, right? You can reduce the number of particles. So for the first element, if it is less than the second element, it's a local minima. For the last element, if it is less than the second last element, it's a local minima. And for anything in between, if this is the element, it has to be something like this. So current -1 and current +1. So if it is in this particular state, then this is a local minima. Yeah, and this guy cannot be, like I was thinking maybe this guy can also be a local minima. No, because we already know that this is less than this guy. So if you go in here, this is less and this can be less or more, so it becomes a local max and stuff, right? So this can never be a local minima. This can never be a local minima. So we should be good here. So you expand it on this side and you give it. So here you can expand. So 3 is greater, so you give it 2. 6 is greater, so you give it 3. And then 7 is greater, so you give it 4. 9 is greater, so you give it 9. And 1 is less, so you give it this way. But then you also have to start expanding from 1. So you expand from 1. You have to give it 5 like this. So you expand from this side, right? So you expand from this side and you have to say that, okay, I can give it 2. I can give it 3, I can give it 4, I can give it 5, but in here, since it's a minima, there's a dip, I don't want to go, right? And you have to take the maximum of these two things. You have to take the maximum of these two things, because for this particular guy, I could have easily just given it 2, but then that would be not correct interpretation of, like, it wouldn't satisfy your rule of what you're doing, right? So that's one way of solving this problem. That's one way of solving this problem. So in here, you need a queue, you need to find the minimas, you need to first find out the queue and then push it in a queue or an array, doesn't really matter. And then you have to be a little bit careful on how you are, iterating over things. So you have to be a little bit careful on that. So that's one thing. Okay, so that's one thing. So another easier way to actually solve this problem, or efficient way here, is here is you take 2 arrays. Okay, and this will come with more complexities. So what we can do here is that we can give this guy 1. So this is less, so you give it 1. This is less, so you give it 1. This is less, so you give it 1. This is greater, so you give it 2. Greater 3. Greater 4. Greater 5. Again, less, you just reset it to 1. Okay. So if the current is greater than current minus 1, you say current minus 1 plus 1. Okay. But if it is less than current plus 1, current minus 1, you give it 1. You take a second one and you do it from the other side. So you give it 1 and you start from here. Greater 2. Less 1. 1. 1. 1. Greater 2. 3. 4. Now from both arrays you take the maximum. So this is 4, 3, 2, 1, 2, 3, 4, 5, 1. What is the sum? 7, 10, 15, 19. Wait, 15 plus 9 is 26, plus 1 is 27. Wait, 25. 4, 3, 2, 1. 2, 3, 4, 5, 1. 4, 3, 2, 1, 3, 4, 5. So my maths is very bad. 10, 15, 19, 20, 25. Yeah, my bad. So, okay. Cool. So let's actually code the solution out. Min reports. So int length is this thing. Okay. So array 1, I'm just gonna say is this thing and this is this. So one of the things is, if length equals 1, you can simply return 1. And if this is this, you have to return 3 for sure. Okay, you have to return 3 for sure. If it is 3, I have to return 5. 6. 1 plus 2 plus 3. No matter, no. Because if it is 8, 1, 9, then you can give 2 plus 1 plus 2. So then this would be 5. So it kind of depends. So we can do this, my bad. We can do this generalization till the point of 2. Okay. And we can say if it is less than 3, 2 into n minus 1. That would work. So 4 minus 1, 2 minus 1. So I think that's good. Okay. Cool. Next thing what we want to do in here is that, so we want to go from left to right. For I less than 10. So in here, array 1 of 0 is 1. So if suppose of I, so we have the logic in here, is greater than suppose of 1, array of 1 should be this also, else it's just gonna be 1. That's the logic, right? And you can do the same thing for, so array of 1 can be replaced with array of 2. My bad, array of 2. Yeah, so this is this. And in here, length minus 2. Well, we have to go from the back. Yeah. And then in here should be greater than equal to 0 and the same. Okay. So if it is greater than I plus 1, array of 2 of I should be equal to this thing. Else it just can be 1. Did we do that right? I think we did that right. Okay. So int max candies is 0. For int I equals 0, then max array of 1 of this thing and max candies plus equals this, and you can just return. I think it's called max reward, so I'm just gonna say max rewards. The candy question was from Leetcode, if I'm not wrong. Yeah. And this here, even though we iterate twice, it's still an O of n operation, amortized, not amortized, it's an actual O of n. And in here you are again using auxiliary space of O of n, because you have two arrays of the same length that you do. So it works. Test should work, because again, like I mentioned, I solved the same problem multiple times before, even on Leetcode. I already found it and solved it. Did I mess up? Oh yeah, previously I did mess up, but then I solved it. And somehow it's slow. Well, I did it with Python. What if I do this with Java? Is that slow? Can I, without much work, copy paste this problem in here? So this is code, right? I can change that and that should be it. I mean, it doesn't confirm with the correct things. Scopes. That is quite fascinating. And do we do it fast? What the fuck are we doing? Hold on. So here, okay. Giving candies to the children are subject. Each child must have at least one candy with high rating gate mode. Okay, return the minimum of candies if you have this. But we do this always, right? So what was the issue? Output is 3, but you're expecting 2. But we always set to 1. That's fascinating. System out print arrays string array 1, and I guess here you can copy array. We didn't bring the test case, that's not the point. Oh, okay. Because we did this kind of shit. Okay, because we did this kind of shit. Otherwise, it should be working. So we did this thing in here because for our other problem which we are solving, kind of says that okay, yeah, it kind of says that it's unique, right? It says unique, so we can put that in here, but not in here. Yeah, it's still kind of slow. Still kind of slow. I wonder if we can do a little bit faster in here. What can we move fast? What if I submit it again? Is it that kind of shit? No, somewhat similarly. Complexity should be of n. That's for sure, yeah. And your space complexity should also be of n. But I'm interested in what this guy is doing. Okay, so you're just taking one single array, that's the thing. Give one candy to everyone. Okay, you only change it. Okay, well, that makes sense. But then you have a, I mean, I also have that block, so that is nice. Then you go from right to left, but you always give, so you can always do it with one array. That kind of makes sense, right? Because you can always do it with one array, because anyways you would be taking the maximum. And that maximum would be determining your next value, depending on which side you travel. So maybe in our case also, we can say this thing in here, okay? Yeah, we can do that. And in here, what we can do is array of 1 and this thing, but max of array of 1 of I, or this thing, whatever it is. If we are not doing that, let it be whatever it was. Let it be whatever it was. And in here now, for int reward in array 1 max, that should also be. Let's quickly check that we did everything right. So we can do with one array, so that's quite nice. Okay, that's quite nice. We should have already thought about that, but we didn't, so that's quite sad, but we should have. In here, let's see if it actually does something. But in here, we have to do that. Well, it really doesn't matter, but yeah. Because you have to say this is candy. This doesn't, not an issue. Okay, this works fine. If I do a submission, now this is interesting. Because you did a secondary, time almost went 5 times, 6 times. Now that's a thing to do. Candy. And this is a blog idea. Using 2 arrays. Using 1 array versus 2 arrays. Same logic. With more with not more branch, same logic, so it's obviously the same thing. It's almost 6x faster. Yeah. That's quite something to look into. That's quite something to look into. Yeah. But for now, I think that's it. It's already 11:30, and I've been streaming for almost 2 hours now. I have been working with the Linux kernel for, not the kernel, trying to get the NVIDIA drivers up and running for almost quite some time now, for 2.5 hours. So in here, I want a long format. Okay, so you already have this, so I'm gonna go to Ignora. Not type. Okay. Video. My bad. Okay. So you have this kind of stuff. Solutions from Algo Expert. Yeah. So you can find all the code in here. GitHub.com, video interview preparation. You can find all the code in here. I'll put it in the chat. I'm gonna put it in the chat for it. If anybody is interested, this is something that I'm building up which can help folks or me go back and look up. I don't think it's Java 24 is a good thing in here, but it's Java 5. Okay, yeah, so this particular repository is supposed to be a single stop solution to do a revision sort of thing. So any kind of algorithms, any kind of system design, any kind of OS operating, computer fundamentals, things like that. I'm gonna slowly and steadily build up the resource base so that it kind of has everything in a single repository. So it's easier for me to go back and do revisions if someone else is referring to this repo. It can be useful to you too. So that's one thing that I'm thinking about this repository. But yeah, another thing is that okay, over time I have all the solutions in the same place, and if I have to quickly go ahead and do a preparation of some sort, I can quickly go and remember, oh, largest range, how did we do it? We have this thing in here, right? And we forgot to do this thing, minimum rewards. So let's actually ask ChatGPT because I gave it a lot of data. And let's see if it can actually do what I asked it to. With all the context I gave it, not to shit around. I hate this EM dash thing, but each student gets at least one reward. They can hurry in it with all values of 1. Scan from left to right. If score of I is this, reward must increase. Reward of score of I must increase. Must be score of I minus 1 plus 1. Scan from right to left. Math.max of existing reward that I does this thing. And I hate this EM dash. It's a far better thing, in my opinion, but whatever. Cool. So we gotta do a quick workout here. Okay, B. Yeah, this is what we changed. And I suppose line patching notes. So yeah, that's basically it, and we push right into the repository. So that's gonna be for today. We already solved around 6 hard questions, and yeah, let me know if you guys enjoy this series of algorithms. I'm trying to do multiple series and explore programming and also see what is good for in general, because the content creator also, you have to think not only about what you want to learn, but I also want to think about what people want to watch. So have to come up with some midpoint, right? So yeah, I'm still thinking about that. But yeah, do let me know in the comments that what kind of things, what kind of contents you like, if this particular series is actually helpful to someone. And yeah, thank you so much for joining. Thank you everybody who joined today. Thank you everybody who joined today. Thank you so much. It's already 11:30 here in our night, and yeah, I'm gonna have quick dinner and then go off to sleep. Today's Friday. I hope everybody had a good Friday, and tomorrow evening I will come online again if I'm feeling well. But yeah, thank you so much for joining, and see you soon next time. Bye bye.